The topic is understanding KEDA, that is Kubernetes Event Driven Autoscaling. I will explain you theory part of it and as well as a project in which I will do or perform the practicals and do the KEDA project. Let's begin. First, let's understand what is the full form of KEDA. It is Kubernetes Event Driven Autoscaling, which means KEDA is an open source CNCF component that automatically scales container workloads in Kubernetes based on exact number of events waiting to be processed. It safely extends native Kubernetes autoscaling beyond CPU and memory. So simply, KEDA or Kubernetes Event Driven Autoscaling is a component in CNCF or component in which we use or enhance the concept of autoscaling. We know that Kubernetes offers autoscaling, which is great. Like, it offers autoscaling, which means if certain resources and CPU memory is, it will create new pods and resources, eventually be doing autoscaling. Kubernetes does it, which is great. But event-driven autoscaling is an enhanced concept where Kubernetes event-driven autoscaling KEDA performs autoscaling where it is triggered by an event, not due to CPU and memory, which is a part of it, but it is triggered by events, not solely due to CPU and memory, which is the default of Kubernetes without KEDA. So what are the key features and use cases of KEDA? Unlike traditional autoscaling, which only checks pod resources usage, KEDA, that is Kubernetes Event Driven Autoscaling, continuously monitors over 60 external event sources. It can be either Kafka, RabbitMQ, AWS SQS, Azure Service Bus, and Prometheus, and all other external event sources. This simply means that it doesn't operate solely on CPU utilization or memory utilization, which is the default of autoscaling in Kubernetes, which means that if we would be performing or adding certain details in the YAML file, that would mean if certain threshold of resources are hit, pods must be created after certain threshold is hit. It can be either 80%, 70%. It depends on your needs. If that certain threshold of memory or CPU is hit, then new pods are created, which is default of Kubernetes autoscaling concept. But we can enhance that autoscaling by making it event driven, which is simply to provide better user experience. Rather than user waiting for 1 or 2 minutes more, you can reduce that to few seconds depending on how you create or manage events. So it offers scale to zero, meaning KEDA supports scaling applications completely down to zero when idle, saving significant cloud compute cost. So if your application has certain microservices or services where it doesn't need to be present when no user is using it, meaning if there is no one accessing that resource, there should be no point of that resource to exist. If that is in your application or your website, then event driven is a great concept to implement. What it does is, if that microservices is to be triggered or is to be present in the queue of access, then KEDA will detect that and it will trigger the event driven autoscaling, which would create pods depending on how much queue or how much traffic is present, not specific to the threshold of CPU and memory, which is the default of pods. That simply means if it was usual default scenario of Kubernetes autoscaling, that would mean a single pod to be present. It can't be a zero pod, and certain threshold of 80% or whatever, that must exactly be hit, or it must hit that threshold in order to trigger a new pod or autoscaling. Whereas with respect to KEDA, it is not like that. With respect to KEDA, it is somewhat like it is triggered by events and traffic or queues that is present, which is kind of related to memory or CPU, but it is not limited to it. It is just like traffic is being in the queue or in the backlog, so it triggers with respect to that traffic being present, which necessarily shouldn't be like it is occupying certain resources. It could occupy, but Kubernetes autoscaling is a reactive approach, whereas KEDA event-driven autoscaling is an proactive approach to autoscale. It is event-driven, meaning as soon as an event enters the queue, example a new message or an API request, KEDA will instantly scale up the pods required to process the load. And it is native integration. It works alongside standard Kubernetes mechanism like the horizontal pod autoscaler HPA, translating our custom metrics into scaling instructions. How does it work? KEDA operates using two main components, which is KEDA operator and the metrics server. there exists ScaledObject CRD. We define a custom resource in our cluster called ScaledObject. This maps our specific deployment to an event source and sets minimum or maximum replica boundaries. Monitoring. KEDA polls our event source to see how many events are pending. Then exists autoscaling. KEDA feeds this metric count into the Kubernetes horizontal pod autoscaling, that is HPA, which then scales our pods up or down accordingly. So simply it has the core components of Kubernetes and it uses it in order to provide enhanced user experience. So it is not different from Kubernetes, but it uses core of the Kubernetes autoscaling concept and provides enhanced or better user experience related to scaling and availability. That was about the theory concept and an overview on KEDA as an open source service for event-driven autoscaling. Now let's understand the practical of how I performed KEDA concept as well as cron. So first, it is the root directory of my application, that is Resume Azure DevOps, and I created a new folder in which I added the default or the configuration YAML files, simply the YAML files of my previous project that was already working. So these are the default YAML files of my application, which include service YAML, deployment, database YAML, and API secret and database secrets. Then I updated the deployment YAML file for replicas that would be 0. Previously it was 2 replicas and I wanted to apply the concept of cron jobs and as well as KEDA. So I made the replicas with respect to crons, which would be 0. So there would be 0 pods that would exist by default, and it would only be triggered to the desired pods with respect to the cron jobs I will prepare a few moments later. And it is same with respect to the deployment of the database. It is replica count 0. I saved this deployment YAML with 0 replicas of database and application deployment, and I applied the kubectl apply -f with all these YAML files. And as you can observe by kubectl get pods, there is no pods that is running, meaning our apply command really worked with 0 replicas. So by default, we can observe that there is no pods that are running. Now to perform KEDA as well as cron jobs, next is to install and add repositories for KEDA, and for queue or streaming of events, I am using NATS Jetstream, which would mimic the users entering or triggering the queue or the load. I'll explain that later, but let's first understand the repository I'm using first. Repository I'm adding, that is helm repo add KEDA core, that is with the link KEDA core GitHub charts, and I performed helm repo update, helm install KEDA from KEDA core /KEDA. I created namespace with KEDA create namespace and it was successfully deployed. Then I confirmed kubectl get pods with the namespace KEDA. We can observe that all pods related to KEDA are up and running, which is admission webhooks and KEDA operator. Then I added repository for installing NATS Jetstream. So I performed the command helm repo add NATS with the link of the NATS GitHub with respect to helm charts, and I updated the repository and I created the namespace NATS system and I installed it within the NAT system namespace, and I set the jetstream.enabled is equals to true, which means that Jetstream is enabled. It was successfully deployed. I confirmed it with kubectl get pods within the namespace NAT system. We can observe that NATS 0, it is up and running, and NATS box is also running. After doing it, here's the important step. We need to install NATS CLI, that is NATS command line interface, which gives us access to certain commands which will work to create streams or load, which would mimic users entering my application and triggering the event-driven autoscaling. Simply, it doesn't operate on default CLI or the commands of what we usually use. We need certain commands with respect to NATS, so we need to install the command line interface of NATS Jetstream. In order to perform that, I head back into the GitHub of NATS.io and I installed NATS 0.40 Windows AMD zip file. I already had tools folder in the local C directory. I created NATS CLI folder and I pasted nats.exe file, which I just downloaded from the GitHub, and I head back into the system properties and environment variables to add NATS CLI path of that exe into the environment variables so I can access this CLI. This is the prerequisite of accessing or using the NATS CLI. After it was successful, Now it's time to create a cron job or a YAML file to trigger the pods or auto scaling. To do that, I created a new YAML file naming KEDA inside the KEDA folder. Now by default, as we change the configuration, it is running on 0 pods for deployment of application as well as deployment of database. So by default, there is 0 deployment files. Now, as we have performed or installed KEDA, which supports ScaledObject and other components, which says that we can scale up from 0, not from a single pod. So as we have observed before, by default, we have changed the configuration into 0 pods. Now we are preparing a YAML file to trigger the desired replicas of our application with respect to the timings which we want to trigger at, which is the concept of event driven. Event is like the certain timings in which I want the pod or the replicas to be present on the desired replicas. To perform that, I created this YAML file. We can observe this YAML file. It says API version keda.sh/v1alpha1, which means it is operating on KEDA. The kind is ScaledObject. Metadata is name, resume matcher, cron. Specification, it is targeting towards my application deployment resume matcher GSCR. It would change with respect to your deployment file name. As of now, my deployment name is resume matcher GSCR, so I named it. Minimum replica count is 0, maximum is 3. Trigger type is cron job, meaning it should trigger with respect to the timings of the event. Certain time is triggered, then the event driven autoscaling will scale the pods. So the metadata is time zone Asia, Kolkata, which is Indian time zone IST. Start, which is 00 ***, which means 12 AM IST until 12 of the noon, which means 12 hours of the time frame. In this time frame, if this event is triggered, the desired replicas would go from 0 to 1. So that was the resume matcher GSCR, which is application deployment file. The same is for database. I added the same API version, kind, metadata name is changed to dbcron, which is with respect to database. Specification, target is with the name db. So in the deployment YAML file of database, it has the name db. Minimum replica count is 0, maximum is 1, trigger type is cron, same, time zone is also same, 12 AM to 12 noon, desired replicas is also same, 1, which means I want the event to trigger replicas of 1 when the time is from 12 AM to 12 noon. Then I confirm the pods. By default, it is no resources, meaning no pods are running in the default namespace. Then I perform the command kubectl apply -f, this new YAML, that is KEDA-cron.yaml, and we can observe the result that says ScaledObject.k.sh/resume cron created, and same db cron is also created. I confirm the pods. We can observe that db pod is up and running and resume deployment pod is also running, which means our cron ScaledObject KEDA is working, meaning we successfully managed to perform Kubernetes Event Driven Autoscaling with respect to cron, that is time driven. Certain time zone or certain time frame is provided in that YAML file. Within that time frame, if the event is triggered, the desired pod will be present. That was about cron. Now let's try or perform the stream or queue or load related autoscaling, which is event driven. But first, let's delete this ScaledObject and cron jobs. So we are starting it as fresh for NATS Jetstream concept. So to do that, I performed kubectl delete ScaledObject, resume matcher cron, and dbcron. So ScaledObject is deleted, meaning resume matcher cron and dbcron is deleted from the default namespace. And I scaled the deployment db to replica 0, and same for resume matcher GSCR replica 0, which means it is now down to 0 pods. I confirmed it with kubectl get pods. You can observe that no pods are running. So let's now perform or do the NAT Jetstream. In order to do that, I head back into the KEDA folder and I updated the deployment YAML files again. Now by default, I don't want it to be 0 replicas. I want it to be at least 1 replicas to be present. I will explain why in the later part. So I changed the YAML files with the replicas 1 for database and for deployment of resume matcher GSCR application. Both have 1 replicas present. Previously it was 0 replicas. Now it is 1 replicas by default. I'll explain the reason later part of this video. Then you will understand why I made it from 0 to 1. Then in order to save some time, I created this shell script to apply the default or YAML files that are not related to KEDA concept or any other thing. So this is a default configuration YAML files which I mentioned earlier in this video. So I pasted all these commands, all this apply of configuration YAML files, that is default configuration files of my application. That includes deployment of application, database, secrets and service configuration map YAML files. Then I performed chmod-x to give execution permissions to this shell script which I named without KEDA.sh. Then I executed this shell script, which means now the pods would be running with 1 replicas, not 0. I confirmed with kubectl get pods. Now you can see it is up and running with 1 pods each. Previously, when we performed the same command, it was 0 pods. Then it's time to create the YAML file for Jetstream. API version is app/v1, kind is stateful set, metadata is named NATS, namespace is NATS system, specification, service name is NATS, replicas 1, match label with NATS name, containers name NATS, client container port is 4222, cluster port is 6222, monitor container port is 8222, and there exist volumes, config map, added the configuration map with respect to NATS Jetstream, which says it to listen at the ports 4222 and 8222. Memory storage would be maximum 1 GB. Now for exposing the monitoring port, this is the service YAML which is inside this same YAML file. Now it's service configuration with respect to opening or exposing the cluster IP of monitoring port. It's in the namespace NATS system, name NATS, and the client port is 4222, cluster port is 6222, and monitoring port is 82222. And this is the configuration for service headless stateful DNS. And here's the important concept, that is ScaledObject for KEDA Jetstream. I added the API version KEDA.sh v1 alpha 1. Kind is ScaledObject. Metadata is named resume parser Jetstream. Namespace is default. Specification, it targets the application deployment file resume.jscr. Minimum replicas is 1. As I mentioned, I am now aiming for minimum replicas, that is 1, not 0. Maximum replicas can be 15. Cooldown period is 10 seconds. Polling interval is 10 seconds. And this is the fallback and autoscaling configuration. Then important part is triggers. The type is NAT Jetstream. Metadata is lax threshold, that is $streams is resumes. Consumer is resume parser. Account is $G. And the host namespace monitoring path is nats headless dot nats system dot svc dot cluster dot local with the port 8222. So this is the configuration file that includes stateful set of memory only Jetstream configuration map with Jetstream enabled memory store, cluster IP service exposing monitoring port configuration, headless service for stateful DNS configuration, and file and the most important scaled object with explicit connection and safety fallback and rapid scale down configuration. You can do the configuration with respect to the official documentation of KEDA, but this is with respect to my application. It totally depends on how your application works. After successfully creating this YAML file, I created another shell script which is kubectl apply of this YAML file -f KEDA-jetstream.yaml and kubectl get svc-n namespace NAT system to name the services within the namespace NAT system, and kubectl get scaled object resume parser Jetstream. And this command is to see the status of scaled object resume parser Jetstream. And final command is kubectl port forward, that is pod /nats-0 within the namespace NAT system within the ports 4223 map to 4222 and 8222 map to 8222. So this kubectl port forward is port forward both monitoring and NATS server. Then I gave permission by performing chmod-x with this new shell script KEDA-jetstream.sh, and I ran this shell script. This shell script is for applying the YAML file of Jetstream, which is event driven with respect to the triggers and the queue load of users, or triggering not just CPU or memory, just the queue and load. Then kubectl get service to name the services within the NAT system to see the ports and everything, and get scale object to see the update of resume parser Jetstream ScaledObject, and port forward to port forward the client and monitoring of NATS Jetstream. Then it was successful, as we can observe. Stateful set.apps, which is configured. Config map is also configured. Service NATS is also configured. Service NAT headless is also configured. ScaledObject resume parser Jetstream is also configured. We can observe the desired services, that is NATS and NATS headless, which is both cluster IP. We can observe the ports, that is desired 4222 and 6222 and 8222. Get ScaledObject. We can observe that resume parser Jetstream is also available. We can see the status, that is ready, true, active, that is true. Triggers is with respect to NATS Jetstream. And finally port forward, which is 4222 and 8222. As of now, we are done with almost everything. Now it's just time to trigger the events to see if it is working or not. But first, let's observe the default status of pods and pod autoscaling. I performed kubectl get horizontal pod autoscaling, that is HPA. We can observe that KEDA HPA resume parser Jetstream is created. Targets is unknown /5 average, meaning it is not triggered right now. Minimum pods can be 1, maximum can be 15. Replicas is currently 0, meaning nothing is triggered as of now. Then you can observe the kubectl get pods. As I mentioned, it is replicas 1 for both resume matches deployment and database deployment. Then you can observe the services, resume matches service and Kubernetes and DB service. So I performed the port forward for the deployment, resume matches GSCR to access the application. It was successful. We can observe that in the logs, Google API key is loaded, environment variables is also loaded. It is running on the port 3000. I head back into this port and I uploaded the resume. Results were available. You can see in the logs as well. So now you understood the purpose of adding at least one pod. Meaning if I would have made it default 0 pods, I wouldn't be able to perform the port forward the desired time, because the trigger for this KEDA Jetstream is with respect to the queue and load, and my aim with respect to the load was to mimic the users entering quickly and users leaving. So it was not like every user is staying in the application. If it was that, I would have kept it many pods, but I wanted to make it like the load is quite high in a small moment of time and it is low in just few moments, and it is like pods are scaling and pods are scaling down with respect to those load and queue happening. So if it is that configuration, I wouldn't have time to perform the port forward to see if my application is even working with those configurations. In order to debug this configuration or to see if it is working or not, I would at least need 1 replicas of each pod to at least access my application and see if it is working. As I observed that the application is working, now I can update it. And after I observed that the pods are up and running, I changed it back to 0 replicas for resume matcher GSCR, meaning resume matcher GSCR is now same as 0 after I checked the port forward and working of my application. It was just limited to seeing and working of my application. After this comes the most important concept of applying the Jetstream. Now you would understand the importance of installing the CLI, which we just did, because NATS commands are not limited to the usual Linux or other commands. It has certain NATS specific commands which needs to be mentioned to trigger and create events for our application. To create a scenario where we are opting for streams or to see when many users enter your application and it triggering the events for autoscaling, we must first create a NAT stream with the desired username or the name which you want. I gave it the name resumes and consumer name, that is resume parser, and the message or the trigger. So for triggering those commands, it was a manual process. In order to not make it manual, I created a shell script. It would just be a shell script I would be running, and it would be prompting me to enter details within the script while it is running, and I provide the details and the stream would be performed and completed. So first command is to create NATS stream. So the command for it is NATS stream add resumes. You don't add this command into the git bash. Even if you want to do it manually, you would need to use this command in the command prompt of your Windows if you are opting for manual. If you are opting for the shell script method, you can try the same script. I'm pretty sure it would work in yours as well. You can change the environment variables and variables which is related to my application, and it would work. Simply the same command is NATS stream at resumes, and it will prompt into subjects. Then it is automatically entering resumes dot star, and storage, it is memory, retention is limits, max messages is -1, max byte, which means limited, max bytes is unlimited, max age is also not limited, max message size, discard old, dupe window 2 minutes, server is NAT server, which is an environment variable which we mentioned in the YAML files. Then it is a fallback of if it doesn't respond in the 2 minutes of the time frame, then it would echo the command error step 1 failed, could not create resumes. Then if it is successful, it is this echo statement. Then it is NATS consumer add resumes resume parser. Then we are adding the consumer, that is resume parser, which we specified in the YAML files. We specified resumes, and we have also specified resume parser in the YAML files. So it is limited to my application and the configuration files. It depends on what you prepare for your own application, but the format and the template is similar. You can also try to create your own as well. But these are the specific commands. Looks complicated while you observe, but it is simply 3 to 4 commands. First is NAT stream add resumes. Second is NAT consumer add, to add consumer, to add stream. Then third is to trigger the response or add the messages, so it acts as a stream or queue, which means publishing the 10 text messages or 10 messages. Simply 10 triggers to mimic 10 stream or 10 users entering your application at the same time. This is the fallback statements. The main command is NATS pub, NATS pub resumes dot text. It is quote hello message, server is NAT server. If it doesn't perform this command, then it is a fallback statement. Then it is successful, then it shows message published successfully. Until now it is great. Like, we have added a stream, we have added the consumer, we have triggered the messages too. But by default the queue was not leaving, meaning the queue was acting as if it was a permanent user that was accessing the application. If it triggered 10 messages or 10 users, it was acting as if 10 users were permanently present in the application, which is not what I wanted. So in order to make it event driven, like users entering the application and just leaving it, to make it realistic to the auto scaling of event driven, I added another command which is in the step 5, which is to purge or delete the existing queue. So it is not like the users are entering the queue and leaving. So I added this NAT stream purge resumes. Server is NAT server, meaning it would trigger the users and it would wait for some time, which is mentioned here, sleep 0.2, which means it waits for 25 to 30 seconds. Then it creates a purge, which means it deletes those queue which we just created, meaning it creates the consumer, it creates the stream, it triggers 10 messages or 10 users accessing your application, 10 streams accessing your application at one time. Then after some time, 10 to 25 seconds, mimicking those 10 users are accessing application for 20 seconds. Then it creates an event to purge those users in the queue. So it would be like users entered for 20 seconds and they just left, and performs events or auto scaling with respect to this scenario. I hope you get the point. After saving that shell script, I gave permission for execution, that is chmod-x with KEDA stream run.sh, with this script of running the application, with ran this script to create stream, create consumer, add the stream or the queue, delete or purge the queue or stream. After I performed it, it looks like this. We can observe that it says life cycle of the test is successfully finished. We can observe that it published 15 bytes to the resume.test. And it also says 10 test messages, meaning 10 streams or 10 load is triggered, which is an event in itself. Then we can observe the step 4, which says it is holding the queue, holding those 10 test messages or 10 queue for 25 seconds, which would give us the time to observe that the pods are creating. Then after 25 seconds, it is automatically deleting or purging NAT stream or this queue, to make that the users just entered the application and just left. So it is completely like event driven and cost effective strategy. Then it says purged 18 messages from resumes, meaning it was successful, and we can observe the state as well. Messages is 0, and we can see the stream wiped successfully. We can watch the status of the pod to see how it works. So that was the backend part of how the script worked. We can observe the real-time situation of how it happened. For running the script, I already had these commands in separate terminals, so I could see how it was working. So I had performed this command kubectl get HPA -w, which is like watch. So by default, KEDA HPA resume parser Jetstream, which is referencing to the deployment of RabbitMQ GSCR, was default, which we already observed. It is 0 replicas, unknown pi average, but after some time the event was triggered with those messages and wait for 25 seconds. So it went from unknown to 10 out of 5 average, meaning it triggered 1 replicas. Then it also triggered 5 out of 5 average targets, meaning it also triggered another replicas. So it went from 0 to 2 replicas. Then after 25 seconds, it was purge and delete of those existing test queue or the messages, whatever stream. So it went from 0, 1, 2 replicas to back to 0 replicas after those queue was purged or deleted. That was about HPA status or kubectl get HPA watch. We can observe the real time of the pods, what happened to them. I performed the same command before running the script. That was kubectl get pods -w. DB was already at 1 replicas. I only changed RabbitMQ GSCR to 0 replicas, so it was by default 0. So we can observe that it triggered pending init pod initializing and triggered 2 pods that are running, and after 25 seconds it is terminating those pods. And after some time I performed kubectl get pods, and it was only DB pod that was running, not RabbitMQ GSCR, meaning it went from 0 pods to 2 replicas of those pods and back into 0 pods. That was the life cycle of stream or users entering the application for some time and just leaving, and it triggering the event driven autoscaling and autoscale down. And when I encountered errors and I was debugging, I had to perform certain commands to delete ScaledObject, stateful set, pods and deployments. So it was 3 to 4 commands that I was constantly performing. To save some time, I created another script to refresh the Jetstream information and perform the commands. I created this another shell script, which was kubectl delete ScaledObject resume parser Jetstream, kubectl delete stateful set NATS names within the namespace NATS system, kubectl delete pod NATS -0 within the namespace NAT system, which is force grace period is 0, and kubectl scale deployment RabbitMQ GSCR replicas 0, meaning this script is to refresh the KEDA Jetstream results. If the results were not as what I supposed would happen, then I would perform this command so it was fresh, and then I performed the commands again and the scripts again to see the application until it worked. So that was about the concept of KEDA, that is Kubernetes Event Driven Autoscaling. I have explained you theoretically how it works, what is the purpose of it, and we also observed how I created and managed Kubernetes Event Driven Autoscaling. First, we have observed cron, which was within the certain time frame and time range when replicas would be scaled, and we observed the NATS Jetstream to mimic the stream's load of users entering and leaving the application, and events that would trigger the pods creation, pods autoscaling, and pods autoscale down with respect to those events. So that is it for the video today. I hope it was simple and insightful. Thanks so much for watching. Have a great day. Bye.